Everybody, welcome back. We had been talking about the MSP430 hardware and software, as well as its launchpad, and now we are going to look at the basics of assembly language so we can start to do some really cool, awesome things. This will lead us into creating our first assembly program file to blink one of the onboard LEDs, yes. We're going to be using Code Composer Studio, or CCS, from Texas Instruments in our class. This is going to help us with things like writing, debugging, and uploading our assembly program to the MSP430. Though we're going to use this specific CCS tool, the syntax we cover in this video is generic to all assembly language programming tools. I think all, yes. We're just trying to keep it general now, even though we are going to use a specific tool later. All right, so let's take a look at some of the basics of assembly. Assembly files have the extension .asm, like main.asm. That's how we indicate to the CCS or any assembler that we're programming in assembly. Every line in an assembly file it can obviously be empty, yeah. A line that isn't empty is either an instruction, a comment, or an assembler directive. There's really a fourth, but it isn't something that we need to be concerned with in our course. All of the lines that are not empty are referred to as statements. So a statement is either an instruction, a comment, or an assembler directive. Now the meat and potatoes, that is the one that we're going to devote most of our time to studying, is the instruction statement. Like when you think about assembly, when you think about programming, this is the statement that you're thinking about. This is just one level of abstraction higher than programming in binary. Programming with mnemonics allows the assembler and the linker to determine which memory location is best. And we don't have to keep track of it. And that's really a very nice thing for us, as you'll see when we look at address labels, because it's a pain in the old you-know-what to keep track of addresses. Every instruction statement is an actual instruction that will be inserted into memory. The statement is partitioned into 4 fields, right? And each of these 4 ordered fields, or the 4 ordered fields, are address label, mnemonic, operand list, and comment. Sometimes we will refer to the operand as an operand list. Remember, a mnemonic can have just one operand that lists several items of additional information. So now shown in this figure is an example code. It's pretty simple code, right? Don't try to run this. But it's illustrating the 4 fields. As we will soon learn, white space separates the fields. The 4 fields are usually aligned in column-wise, as shown here. It's good programming practice, but not necessary to align the fields. You can actually put as much white space between the fields as you want. You can use 1 space if you want, but that would look like absolute garbage. You probably don't want to do that. The first field, the address label, must begin in the first column of the file. So that means there cannot be any white space before the address label. If there is, the assembler will misinterpret it as the second field instead of the first. The purpose of the address label is to define a point in the program that can be referenced by other instructions. So think looping or conditional statements. In this figure, the address label is loop, capital L-O-O-P. Notice how it starts in the first column of the file and no white space precedes it. A colon may be placed after the address label, but it's optional. And the reason you would put a colon, although it doesn't work in my situation here, is that some editors will display the address label as a different color. So you see that's not the case really in my figure here. That's because I have CCS set to a dark theme that just does not want to light it up in a different color. Wah. Let's remember the colon though, or let's point out that the colon is not part of the label, so we leave it off when we refer to it. You'll see actually the word loop appear later on in that small little program, and you'll see that the colon is left off because loop with the colon, or the colon is not part of the address label. It's just simply loop. Okay, so as I said, having address labels helps us tremendously. It allows for easy looping and conditional statements like we don't need to know or set the address of looping instruction or the conditional statement instruction. Instead, we just tell the assembler, or, we let the assembler create that address itself. Now, the second field is the mnemonic, which we've seen before. Since fields are separated by whitespace, the mnemonic must be preceded, that is, by whitespace to indicate that we are not in the first field. The whitespace, as I said, can be a single space or it can be a tab, multiple spaces or tabs. It can be a combination of whatever, but usually you'll want to use spacing so that all of the mnemonics are aligned. So in the figure, we see the mnemonics MOV, we see mnemonics DEC and JNZ. Notice they are all aligned column-wise. Again, that's good programming practice. It helps with the readability of your code. And it's also important to note that mnemonics will never begin with a semicolon. Just keep that in mind for when we talk about comments. And as you learned before, mnemonics are descriptive names for opcodes, and they're recognized by the assembler and then converted to associated binaries. That way, we don't have to remember the binaries. The mnemonics, of course, are easier to remember, and actually that's why they're called mnemonics. They're easy to remember. The third field is the operand. It also must be preceded by whitespace. Again, how much whitespace is up to you, but typically all of the operands are aligned with one another. So in the figure, we see from top to bottom, hashtag 3210H, R4, that's one operand, then nothing, then R4, and then loop, and then nothing. And so all of the lines there, all of the lines with something, are all aligned with one another. And again, I want to point out that operands never begin with a semicolon. And just to emphasize, the word operand means the mnemonic's entire list of additional information. So a mnemonic requiring an operand has exactly one operand, though there may be more than one item or piece of information contained in that operand. So in the example, MOV has one operand with two pieces of information, each piece separated with a comma. The DEC mnemonic also has one operand, but its operand has only one piece of information, and same with the JNZ mnemonic. And remember that some mnemonics don't require an operand at all. As we said, operands are additional information needed by the mnemonic, that is, to complete the instruction. Right? We got to tell it what address we're going to move where. Right? We got to tell it what address label to loop back up, like the JNZ mnemonic tells us. All right, the last field is the comment field. Of course, by now in our lives, we all understand why commenting is important. The comments in assembly begin with a semicolon and are line comments, so everything after the semicolon is ignored by the assembler. Comments can be on their own line, and they can begin actually in the first column without being preceded by whitespace. This is because none of the other fields are allowed to start with a semicolon. So when the assembler sees the semicolon, it knows the line is a comment. So if the mnemonic does not have an operand, the assembler won't confuse the third and fourth fields because comments always start with a semicolon. All right. Recall that a statement can either be an instruction, a comment, or an assembler directive. We just covered the instructions and its and an instruction's four fields. But we've also now just covered a comment. So the last is the assembler directive. The assembler directive, well, It's a statement that tells the assembler information about the program, but is not an actual instruction. So for example, they may allocate variable space in memory, they might manage global variables, or they may establish constants. Linkers use these directives to link together multiple files and combine them into one project. An assembler directive begins with a period and must be preceded by a space. Because it's preceded by a space, actually, it usually aligns with the mnemonics. In this figure, text, retain, and retain refs are 3 directives. They are each on their own line, they all begin with a period, and they are each preceded by white space on their respective lines. So notice how these directives all align with each other, and also the move mnemonics below them in the column. Again, that alignment is optional, but it's very good programming practice. All right, so that is all I think we need to say here in this intro to assembly. That's the anatomy of an assembly program. And now I think we're in good shape to start programming. So in the next video, I think we're going to start working towards a Blink program. So I will see you then. Thank you.